What is the integer that is greater than root 11 but less than root 19? So we want an integer between root 11 and root 19. Well, I could put, say, a root 9 here, and I could put a root 25 here. That allows me to actually make actual integers. And this guy is, of course, 5. So an integer, obviously, between 3 and 5. And that, of course, is 4. What is the value of? So we got 3 to the power of 5 minus 3 to the power of 4 over 3 to the power of 3. And you can factor. I know what they're doing. They're trying to factor things. And we can do that way if you really wanted to. And if you do that, then these guys cancel. And then you're just left with 9 minus 3, which is 6. Or you could just do it the long way, which in some strange way I prefer, which is that, and then just crunch out those numbers, and that gives you 6 also. The measure of the interior angles of a quadrilateral are 1, 2, 3, 4. Determine the measure in degrees of the smallest interior angle. So the ratio is 1, 2, 3, 4. Okay, well, I'm not going to attempt to draw it, but in any quadrilateral, whatever it looks like, the measures of the interior angles will add up to 2 times 180, right? Because it's 2 triangles, as I show here. So the measure of the interior angles would add up to 2 times 180. So if we call the angles x, 2x, 3x, and 4x, since that's the ratio, and you add them up, it'll be 360 basically. So that's some very simple algebra. That's 10x, and therefore x is 36. And what do they want? The measure of the smallest, well, the smallest one was x, and x is 36. So 36 degrees is the answer to that question. Determine the integer equal to. Okay, well, I guess I could just add them. Or I could maybe do a little bit quicker. That one and that one is 30, 30. And then that one is also 30, 30. And similarly, if you keep grouping pairs of 2's like that, they all are 30, 30. And then this one is, I guess, left over, so that's not 30, 30. So we have 1, 2, 3, 4, 5, 6 of those that are 30, 30. Oh, no, sorry. 1, 2, 3, 4, 5. 5 of those. And then 15, 15. And then when you do that math, it's 6, 6, 6, 5. Or you could just add them straight. I mean, it doesn't really matter how you do it, as long as you get the right answer. What is the smallest 8-digit positive integer? That is exactly 4 digits, which are 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, well, the first guy has to be, it can't be a 0. So the smallest it could be is 1. And then, And then similarly, every digit after that should be as small as possible. But we want to put in 4 of these 4's. So I'm going to put those at the very end. And that will allow my digit to be as small as possible. And then these guys, we want it to be small as possible. Now, at first I thought, okay, just 1, 1, 1. But here's the thing. They could be zeros. The first one cannot be 0. Can't be 0. Because if the first one was 0, it would not be an 8-digit number. But the second, third, and fourth couldn't be zeros. So a little bit of thinking is all that is required to come up with that number, which I believe is the answer to the question. On Fridays, the price of a ticket to a museum is $9. On one particular Saturday, there were 200 visitors to the museum, which was twice as many visitors as there were the day before. The total money collected from the ticket sales on that particular Saturday was 4/3 as much as the day before. The price of the tickets on Saturdays is K dollars. Determine the value of K. Friday, Saturday. So on the price on Fridays is $9. On Saturday, it's K dollars. And the visitors was 100 on Friday and 200, I believe. And the total, therefore, would be 9 times 100, which is 900. And this is going to be 4/3 as much, so 4/3 of 900, which I believe is 1,200. Now that 1,200 is also equivalent to this K times the 200 visitors. So therefore, when you solve for that, K is 6. What is the smallest 4-digit positive integer that is divisible by 15 and 9 and has only even digits? Okay, so 4 digits. If it's divisible by 5, this last guy has to be either 5 or 0. But all the digits have to be even, so we can only put a 0. 0 is even, by the way. 5 is not, obviously. So that one has to be a 0. We want the smallest possible 4-digit, so this number has got to be a 2. Now, you might say, well, why not 0? Because 0 is smaller than 2, but if you put 0 there, it would not be a 4-digit. It would be 3-digit or whatever it would be, but it wouldn't be a 4-digit. So I got those two. Now to get these guys. These guys I'll call A and B. Now we want it to be divisible by 9 also, and then there's a divisibility rule. Divisibility. Amazing how many I's are in that word. Divisibility rule. And there's divisibility rules from all the numbers, I think. But for 9, the rule states that if a number is divisible by 9, the sum of the digits is divisible by 9. Sum of digits is also divisible by 9. So in this case, the sum of the digits would be 2 plus A plus B plus 0, which is just 2 plus A plus B. And this guy has to be divisible by 9. So that means that 2 plus A plus B has to be either 9 or 18 or 27. It has to be divisible by 9. So let's go with this one. A plus B equals 7 then. Well, we can only use even digits. So A and B can be either 0, 2, 4, 6, or 8, right? But there's no way you can get A plus B equal to 7 with a combination of those guys. You try it, it's not possible. So this is not the what's going to work. So let's try another multiple of 9. How about 18? That means A plus B is 16. And with these guys, can you see how can you get A plus B equal to 16? If A equals 8 and B equals 8. So therefore, this guy is an 8 and this guy is an 8. And therefore the number is 2880. So that is the answer to the question. The figure below was constructed by taking a semicircle with diameter 64 and replacing the diameter with 4 semicircles, each having an equal diameter. What is the perimeter of the figure? Perimeter, well, first of all, the circumference of a circle is pi times the diameter, right? But the big guy, the sort of the one on the outside, like that, that's circumference divided by 2, and they even tell you that it's a semicircle. So it'd be pi d over 2. Now d in this case is 64, right? So that means that's 64 pi divided by 2, which is 32 pi. So 32 pi is the one on, I guess, the outside on the top there. Now we have to figure out these little guys, these ones, this little guy and so on. There's 4 of them. So each of them, same thing is pi d. I'll put a small d. And again, each of them, we want half of the circumference since it's a semicircle. And each of those, they don't tell me. Oh, but there's 4 of them, and the 4 equals 64, because from here to here is 64, right? And each of those are kind of like that. So there's 4 of them. That's D, that's D, that's D, that's D. So 4D is equal to 64. So that means D is equal to 16. Okay. So that means C over 2 would be pi times 16 over 2. So that's 8 pi. But there's 4 of those guys, right? 1, 2, 3, and 4. So 4 times 8 pi, and that's 32 pi. So therefore, we've got to take this 32 pi and add it to that 32 pi. And when you do, you get 64 pi. And that's the total perimeter of that figure. How many times does the digit 0 appear in the integer equal to 20 to the power of 10? 20 to the power of 10. So we got 2 times 10 to the power of 10. And there'll be 2 to the power of 10 times 10 to the power of 10. So that's going to be 1024. And then this will just be 10 zeros. So 10, 10, Yeah, 10 zeros, so like that. Okay, so they're saying how many times does 0 appear in this digit? Well, 1 and then 10 times here, so a total of 11. 11 times the digit 0 appears in the number that is equal to 20 to the power of 10. If 3y minus 2x is 4, determine the value of 16 to the power of x plus 1 over 8 to the power of 2y minus 1. Okay, looks like everything's got to be put in powers of 2 here, so that's going to be 2 to the power of 4, x plus 1, and it'll be 2 to the power of 3, 2y minus 1. Okay, so 4x plus 1, sorry, 4x plus 4, I should say, and then 6y minus 3. Okay, so then let's just continue over here. So that's going to be 4x plus 4, using exponent rules, minus 6y minus 3, right? So that's going to be 2 to the power of 4x minus 6y plus 7, I believe. Okay, and then let's split up the 4x minus 6y and then the 7. And then this looks very similar to that, but not identical. But I think I can make it by factoring out a 2, perhaps? Be 2x minus 3y. And then this 2 to the power of 7, I'll leave alone. Okay, this 2x minus 3y would be negative 4 if you just took that original equation and multiplied through by negative 1. So that means this is 2 to the power of 2 times negative 4 times 2 to the power of 7. And then using exponent laws, this is minus 8, and that's 7. And then finally, you just add them. So negative 8 plus 7 is negative 1. And of course, that is a half. So a cool little question to figure this out. Let pi be the ith prime number, for example. P1 is 2, P2 is 3, P3 is 5. For each prime number, construct the point Qi, Pi, 0. Suppose A has coordinates 0, 2. Determine the sum of the angles of the areas of the triangles A, Q1, Q2, A, Q2, Q3, and so on. All right, I think I'm going to have to draw coordinate axes here. All right, and let's see what I get. So that's X and Y or whatever. So let's figure this out. First of all, A is 0, 2. So wherever, let's just say that's 2. So this is A right here. That's my A. And then Q1 would be the first prime 0. So the first prime is 2, right? So 2, 0. So somewhere here. So that's Q1. And then second one, Q2, is the P2 and 0, so that's 3, 0. So that's approximately here. And then 1, 2, 3, 4, 5. 5 would be Q3, right? Because Q3 is 5, 0. And then so on. So Q4 would be what, 7, 0, I think? Q5, what's the next prime after 7, 11? Yeah. Actually, let me label this 2, 3, 5, 7, 11. Well, it's not drawn to scale, but that's okay. How far do I have to go here? I have to go up to Q7. Okay, so a couple more. 13, I guess, is the next prime. And then 17, I think, is the last one. Okay, so now we've got to draw our triangles. So the first one is A, Q1, Q2. So like this, right? And then the next one, A, Q2, Q3. A, Q2, Q3 is this one. And then this one, and then that one, and then that one, and then finally, oh boy, those are not straight lines, those are now curves, but you guys get the idea. Those are just the triangles. Okay, so let's figure out the total area. Total area, do they want the sum? Okay, yeah, so they do want the total, actually. All right, not a problem. The total area, all of these are triangles, so 1/2 base times height. So the first one is there, though that base looks like 1, and the height is 2. The next one that guy, that base is 2 this time, and the height again is 2. I think all the heights will be 2. And then very similarly, you guys can do this 2, and then that one is, I think, 2 again. And then the next one is 4 actually. And then the next one is 2 for the base. Height's always going to be 2, and then that next one is 4 for the base. So this one, all the 1/2s and the 2's actually cancel to give just 1. Interestingly, so you're just adding up 1 plus 2 plus 2 plus 4 plus 2 plus 4, I believe. And that is 15, sorry. 4, 4, 2, 10. 10 and 5, 15. So 15 is the answer to this question. Evariste listed all of the positive integers from 1 to 90. He then crossed out all of the multiples of 3 from the list of the remaining numbers. He then crossed out all of the multiples of 5. How many numbers were not crossed out? Okay, so between 1 and 90, in terms of multiples of 3, just divide 90 by 3. Now, this is how many multiples of 3. Between 1 and 90, to figure out the multiples of 5, you divide by 5, and that'll give you 18. So 18 and 30, there's 48 numbers that are either a multiple of 5 or a multiple of 3. But here's the thing. Some are multiples of both. Multiples of both 3 and 5. So we have to subtract from this 48 those guys because we've double counted them. See, we counted them once in the group here, multiples of 3. We counted the multiples of 5 here, but some are both multiples of 3 and 5, which we counted here and here. So we have to subtract those from this guy. So to figure out the multiples of both 3 and 5, that's technically a multiple of 15, 3 times 5. So you take 90 divided by 15, and there's 6 of those guys. So there's 6 that we double counted. So from the 48, we have to subtract those 6. And when you do, you get 42. Now, these are the numbers that we crossed out. But they don't want that. They want how many were not crossed out. So from the original 90, you'd subtract that 42, and that would give you 48 numbers that were not crossed out. The parabola with the equation y is equal to minus 1/4 x squared plus 5x minus 21 has its vertex at point A and crosses the x-axis at B and F. A second parabola with its vertex at B passes through A and crosses the y-axis D. What are the coordinates of D? Well, let's see if I can graph this. I don't know what it looks like, but I'm just going to make a ballpark estimate here. This original equation has a negative in front of the x squared, so that makes me think that it points downwards, right? That's how it works. So let's say this is the vertex. Let's draw a straight line down. That's sort of what it looks like. And then we are told that we've got a second parabola that has a vertex at B. Now, where's B? B is here. This is B right there. This is B. And this is F, I guess, this point. Now, its second parabola has a vertex at B and passes through A and crosses the y-axis at D. Where's A? Oh, A is here. I should have wrote A instead of a V. Okay, well, same. You guys understand. So the second one, let me see, how is that going to work here? So it's kind of like something like this. Yeah. So it passes through A, its vertex is at B, and then this is where it passes the y-axis, and they're calling that D. And they want me to figure out the coordinates of D. Okay, I think I can do this, so let's see. What's my first step here? I think the first step is to first figure out what is the vertex. Actually, yeah, I think so. So let me take this original equation, y is equal to minus 1/4 x squared plus 5x minus 21. And then you guys know about completing the square, right? Complete the square, and that will allow me to get the vertex, and it'll allow me to get A, B, and F basically. So first factor out the 1/4. That's going to give me x squared minus 20x. And then just leave the minus 21 alone. Then this is a very important coefficient. You take half of it, and then you square it. So that's how you complete the square. So this would be minus 1/4 x squared minus 20x plus 100 minus 100, and then minus 21. So these three guys will factor out very nicely, and it'll be x minus 10 all squared. And then don't forget to kick this guy out. You have to, don't forget about that minus 1/4. So that becomes what, 25, I think? So plus 25 minus 21. And this is, we have successfully completed the square. And what that allows us to do is get the min and max. So what that means that when x is 10, the value of y will be 4. And that is the vertex. So that is the A. This guy right here is 10, 4. So this is 10 right here. Yeah. I know it's not drawn to scale, but that's okay. Okay, so what do I do next here? I've got to figure out f, and b. Well, f and b occur when y is 0. So if I set y to 0 and solve, that's going to give me, let's see here, quarter x minus 10 squared is 4. So x minus 10 squared is 16. So x minus 10 is plus or minus 4. So therefore, x would be, if it's 4, it would be 14. And if it's minus 4, it would be 6. So this would be the 14. And this would be the 6. Okay, that's actually fairly decent progress there. Okay, now I'm going to need a little bit more space. So now what am I trying to do here? I'm trying to figure out the coordinates of D, this guy right here. Okay, I think I'm going to need the equation. So the equation of that green parabola, well, is going to be of the form ax squared plus bx plus c. But I actually want it in the vertex form, which is when it's written like this, y is equal to a x minus h squared plus k. Because that's, I have the vertex, right? Because the vertex is b of that green parabola. So that's going to be a is x minus 6 plus 0. Okay, that's good. So I know that this is just a x minus 6 squared, but I also know that this point is on it. So I can sub that point, 10, 4, and when I do, I get 4 is equal to a times 10 minus 6 squared. So that's going to be a times 16, 4, so a is equal to 1/4. And therefore that original equation is y is equal to 1/4 x minus 6 squared. And then the final step is to figure out d, and that occurs when x is 0. So then for when x is 0, this is going to be 1/4 times 36, right? And that's 9. So therefore the coordinates d would be 0, 9. And that completes this question. Jeff caught 21 fish, each having a mass of at least 0.2 kg. He noticed that the average mass of the first 3 fish that he caught was the same as the average mass of all 21 fish. The total mass of the first 3 fish was 1.5 kg. What is the largest possible mass of any one fish that Jeff could have caught? So F1 plus F2 plus F3, those first 3 fish, divided by 3, they're saying is the same as F1 plus F2 plus F3, all the way until the last fish, divided by 21. And let's just say that's D. I'm not sure what the number is. Well, we're told that the total mass of the first 3 fish is 1.5. So that means that this guy is 1.5. So D is equal to 1.5 divided by 3. And that equals this whole thing. 1.5 divided by 3 is 0.5. So 0.5 is equal to F1 plus F2 plus F3 plus all the way till f21 all over 21. But then again, that's 1.5, so 0.5 is equal to 1.5 plus f4 all the way till f21 all over 21. Okay, I think this is going in the right direction. At least I hope it is. Now let's cross multiply 21 times 0.5 and then 1.5 plus all these guys all the way till f21. And then this is what, 10.5 minus this 1.5, so that'll give me 9. So 9 will be equal to f4 all the way till f21. Now they want, let's go back, the largest possible mass of any one fish. That occurs when all the other fish are as small as possible. And the fish have to have at least 0.2. So the smallest they can be is 0.2. So if I make all of them 0.2, except one fish, which I will call f21, then that f21 could be as large as possible. So let's see, how many of these 0.2s did I do? Everything from f4 to f20, so that is 17 fish, right? So 17 0.2s, and then f21. So that is 9 is equal to 3.4 plus f21. So therefore f21 would be 5.6. And that is the largest that any one fish could be. Suppose that a, b, c, and d are positive integers which are not necessarily distinct. If a squared plus b squared plus c squared plus d squared is 70, what is the largest possible value of a plus b plus c plus d? Well, I think this is one of those trial and error questions. I don't see an algebraic way of doing it. I was thinking about that, but I think that falls apart. So let me explain what I mean by trial and error. The first thing you have to say is we got to figure out a way of making this work. Well, let's start with the biggest number that I could possibly place for any of those letters. If I put 9, it becomes 81. That's already greater than 70. It's got to be less than 9. How about 8? 8 would be 64. And therefore, all the other three guys would have to add up to 6, right? And I think that is possible. So for example, if I made this 2 squared, 1 squared, and 1 squared. If I add these up, 1 plus 1 plus 4, 6, and then 64. So there you go. So that works. So that means my a plus b plus c plus d is 1 plus 1 plus 2 plus 8, and that's 12. They want the largest possible value. Now, is that the largest possible value? I don't know. I guess we have to keep going here. And that's what this is. I really don't see any algebraic way of doing it. I think it's just trial and error. Okay, let's do this again. Let's see what happens. Okay, so I did 8, and that's the only possibility. Let's try 7. 7 squared is 49, so the other numbers have to add up to 21. So I think I can do that. That'll be 16. I got 5 left. 2 squared, 4, and then 1 squared. That'll do it. Yeah, that adds up to 70. So this time my a plus b plus c plus d is equal to 1 plus 2 plus 4 plus 7. And that, I believe, is 14. Okay, we're getting bigger. So we are definitely going in that direction. Now, is 14 the largest, though? Let's see. Let's keep going, and let's see if we can get a larger sum. So we did 8, we did 7. Let's try 6 this time. So 6 squared, that's 36. So that means the other numbers have to add up to 34. Yeah. So if I'd made this a 4 squared, that's 16, and then I need another 18. I think 3 squared and 3 squared would do it. So that would be 70, and then my a plus b plus c plus d would be 3 plus 3 plus 4 plus 6, and that's 16. Okay, and 16 is the largest. And you can experiment and see other values, but you won't be able to get a sum that's larger than 16 for a plus b plus c plus d. In the diagram below, the two circles have the same center. Point A is on the inner circle and point B is on the outer circle. Line AB has length 5 and is tangent to the inner circle. At A, what is the area of the shaded region? Well, let's draw that center, and then let's connect the dots there, like that. And since A was tangent, that's a right angle. So if this is small r, and that is big R, and AB is 5, we have a Pythagorean relationship. So we have r squared plus 5 squared is equal to r squared. And that's about as far as I can go. The area of the shaded region looks to me like pi r squared minus pi small r squared. Okay, and I see that if I rearrange this, it would be r squared minus r squared. Okay, perfect. So substitute that in there. So that would be 5 squared, and therefore that is 25 pi. So all we needed was to use the Pythagorean theorem to get the answer for this question. For each real number m, the function f at x is equal to x squared minus 2mx plus 8m plus 4 has a minimum value. What is the maximum value of these minimum values? Ooh, okay. Well, I think we did this earlier. We got to complete the square, so let's do that. So 2mx, we got to take this coefficient and take half of it, so that would be minus m, and then square it. So that would be m squared. And then we have to subtract that. And then don't forget about these 8m plus 4. So then these three will factor very nicely. And then you've got this whole thing left over. Okay, so what does that tell me? That tells me what? That when x is equal to m, f at m is equal to minus m squared plus 8m plus 4. So that means that when x is equal to m, this is the minimum value. So that's the first part of the question. For each real number m, this function has a minimum value, and that minimum value is this. What is it numerically? Well, it depends on what m is. You'd have to substitute a value, numerical value for m. Then they're saying of all of these guys, whatever you put in for m, of all the possible infinite values, what is the maximum of those? So what you need to do is graph this. Since this coefficient is minus 1, I don't know what it looks like, but it would be something like this. And they want you to figure out the max, so they want you to figure out this topmost, basically, vertex. Okay, that's done by completing the square again. So let's do that one more time. So let's see here. First we got to factor out m squared. That's going to leave me with 8m. And then this 4 we don't need to worry about. And then we have to take this coefficient, take half of it, which is negative 4, and then square it, which would be 16. So m squared minus 8m plus 16 minus 16 plus 4. So then these would be m minus 4 squared, and then 16 plus 4, because remember, you got to, when you kick it out of the bracket, don't forget about the coefficient there. So it'd be plus 16, and then plus 4 would be plus 20. So that means that when m is 4, so for example, if this was m and this is f at m, when m is 4, f at m is 20. So that means that the maximum value of that graph is 20. When m is 4, f at m is 20, and this is the maximum. So yeah, very interesting question. I think it might be a little confusing, but it's really just two completing the square tasks that allow you to come up with the right answer. A sequence T1, T2, T3 is defined by T at n is equal to 1 over 7n when n is odd, and 2 over 7 to the power of n when n is even. For each positive integer n, determine the sum of all the terms in the sequence, that is, calculate T1 plus T2 plus T3, and so on. Well, this so on makes me think that this is an infinite something. Infinite sequence, infinite series. Yeah, it's infinite. And the sum of an infinite series, I believe, is a over 1 minus r, where a is the first term and r is the common ratio. So I think this will be at the heart of this question here. Okay, let's see. First, let's do Tn when n is odd. So when n is odd. So that's going to be 1 over 7 to the power of 1 plus 1 over 7 to the power of 3 plus 1 over 7 to the power of 5 plus 1 over 7 to the power of 7, and you get the point. So that's just going to be the odd ones. So that's T1, T3, T5, and so on, right? Sum, I should put sum here. Sum of Tn. And then when n is even, the sum, because that's what they want, then you're going to use this guy here. That's 2 over 7 to the power of 2 plus 2 over 7 to the power of 4 plus 2 over 7 to the power of 6 plus 2 over 7 to the power of 8, and so on. And I think that's pretty much all there is. And at the end, whatever sums we get, we would just add them to get the total. Okay, so let's utilize this formula. A is 1 over 7 in this case, and the common ratio, let's see here, 1 over 7 to the power of 3 over 1 over 7 to the power of 1. That would be 1 over 7 to the power of 3 times 7 over 1. So that's going to be 1 over 7 to the power of 2. That's the common ratio there. So that's going to be 1 minus 1 over 7 to the power of 2. So that's 1 over 7. So that's 1 minus 1 over 49, so 48 over 49. And that's going to be 1 over 7 times 49 over 48. So that's going to be 7 over 48. 7 over 48, I believe that is correct for that sum. Okay, so we got to do pretty much the same thing, but this time for this guy. So this time the A is 2 over 49, the first term, and the common ratio, let's see here, 2 over 7 to the power of 4 over 2 over 7 to the power of 2. So 2 over 7 to the power of 4 times 7 to the power of 2 over 2 is 1 over 7 to the power of 2, which is 1 over 49. Is that the same as last time? Yeah, I think so. Well, it doesn't really matter. But so this is 2 over 49, and then that's 48 over 49. So 2 over 49 times 49 over 48. So that looks to me like 2 over 48. Yeah. So that's that. So now the grand total would be this guy and this guy. So that's 7 over 48 plus 2 over 48. And that's 9 over 48. And I think I can go a little bit lower terms. Divide the top and bottom by 3. That'd be 3 over 16. So 3 over 16 is the final answer. Pictured below is a rectangular array of dots with the bottom left point labeled A. In how many ways can 2 points in the array be chosen so that they, together with point A, form a triangle with positive area? All right. Well, A is going to be part of the triangle, and there's 25 dots in total, right? 5 times 5. So there's 24 additional dots. And from those 24 additional dots, we have to choose 2 for the other points, right? Whatever the triangle is, there's going to be this dot, and A. So we have to choose 2 dots that together with A will form a triangle. So from the 24 dots, we have to choose 2. So that 24 choose 2 is 276, and you guys know how to do choose notation, right? But here's the thing. That's the total. Not all of those will make a triangle. Why? Because sometimes a line like these two guys down there, right? This guy and this guy, they form a straight line. That's not a triangle. So from this 276, we have to take away all the straight lines, basically. Subtract from this points that are on the same line. So the example I gave right there. Okay, so that's the task. I think that will allow us. So let's put in a couple of graphics here that will be helpful, I think. So these graphics, I'm hoping will be helpful. Let me explain what these are. So this one here shows all the lines that you can draw coming out from A. And as you can see, there's quite a few of them. But some of them we don't need to be concerned with because they don't have any problem dots. The problem dots are the ones that are on the same line. So for example, this one doesn't have any problem dots. Let me see here. This one doesn't either. And so on. But some of them do. The ones that have the problem dots are here. The lines that have the problem dots. And those dots basically are ones that are on the same line. So as you can clearly see, like I drew initially, these two dots are problems. Because if you chose them together with A, they would not make a triangle. They would just form a straight line. So that's what we have to concentrate on. So let's talk about this. So from this line, we have 1, 2, 3, 4 problem dots. And from those 4, we're going to choose 2. And if we do that, they will not make a triangle. So I've got to count all those guys. And then at the end, I've got to subtract them from this number. So 4, choose 2. And then from this line, there's only 2. So from those 2, choose those 2. From this line, there's 1, 2, 3, 4, other than A. So from those 4, choose 2. Hopefully I'm doing that right. And then from this line, there's only 2, so choose those 2. And then finally from that line, 1, 2, 3, 4, choose from those 4, choose 2. So this will be 6, 1, 6, 1, and 6. So that's 20. So finally, from that 276, we have to subtract from it to these 20 that do not form a triangle. And when you do, you get 256. That will form a triangle. So that's the approach to that question. Lila and Isabel run on a circular track, both starting at P. Lila runs at a constant speed in the clockwise direction. Isabel also runs in the clockwise direction at a constant speed, 25% faster than Lila. Lila starts running first, and Isabel starts running when Lila has completed 1/3 of one lap. When Isabel passes Lila for the 5th time, how many times has Lila returned to the point P? Okay. Well, first thing, I'm just going to draw a circle, and then I will divide that circle. Well, let me just put in the dot first, the center dot. And we are told that when she has done 1/3, so approximately here is 1/3. That's Lila, right? Lila. She starts running first, then Isabel starts running when Lila has completed 1/3. So when Lila is here, that's when Isabel starts running. Okay. And then I'm going to divide these further into groups of 4. And they're all identical, even though it may not seem that way because it's not drawn to scale. But let me just explain what I've done. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. 12 equal units, even though it doesn't look equal. That's what I have tried to break this circle into. And there's a reason, and it'll all make sense once I start this table. So we have Lila and Isabel. So let me explain what's happening here. So, and then for each one, I will I'll write just how many units they have run. So units ran, and the units I have drawn in this diagram. Okay, so when Lila has done 4, 1, 2, 3, 4, Isabel hasn't started yet. She's done 0. And then when Lila does another 4, 1, 2, 3, 4, so 4 plus the original 4, now she's up to 8 units. Now Isabel has done 5. Why? Because Isabel, she runs 25% faster. So when Lila has done 4, 25% faster would mean that she would do 5. That's the equivalent. And then just keep going like this. She's already done 8. Let's add another 4. For every 4 that Lila runs, Isabel runs 5. So she's done 5 already, plus the 5 to match with that 4. So now she's up to 10. See the tally that I'm making here? So let's just keep going here. 12 plus another 4, that's 16. That becomes 10 plus 5, which is 15. Let's keep going. 16 plus another 4 brings you up to 20. Then with 15 plus 5, we're up to 20. And this 20 matches with that 20. And that is the first time that they meet. So first meeting. And of course, after that, immediately after, Isabel passes her. And that's what they're saying there. But they meet there, of course. But they don't want the first time. They want the 5th time. So we got to keep going here. Time consuming, right? So let's just keep going here. So I'm going to speed this up a little bit because I don't want to do it by 4s. I was doing it by 4s. I'm going to do it by 12s to make it go a little bit faster. So for every 12 that Lila runs, Isabel will run 15, right? Because it's 25% faster. So we got 20 plus 12, that brings me up to 32. That would be 20 plus 15, would bring up to 35. Got it? So and then just keep going like that. So let's see here. The next one would be 44 and 50. The next one would be 56 and 65. Next one would be 68 and 80. Aha. Now, some of people might even miss this, but this is when they meet again. Now you might say, well, 68 doesn't equal 80. Well, how could they meet? Because at this point, think about it. Isabel is exactly 1 lap ahead. Because the difference between 68 and 80 is 12, but that's 12 units. 12 units is 1 lap. See what I mean? So that's why this is the second meeting. So this is the second meet. Second time they meet. Well, you guys understand. And then you just got to keep going like this. So I'll let you guys do it. It's pretty easy, just adding 12 and adding 15. And then when you get up to let me think about this, 116, right? This will be 140. This is now 24. This is 24. So this is 2 laps ahead. Is 2 laps ahead. And that's the third meet. Third time they meet. And then you keep going. And eventually you get to 164 and 200. That is exactly that's 36. So that's 36 divided by 12 is 3 laps ahead. 3 laps ahead. And that's the 4th meeting. And then finally, we'll get to the 5th one very quickly. And that's when we get to 212. 212, and this would be 260. And that is, let's see here, 260 minus 212 is 48. 48 divided by 12 is 4. So that's exactly 4 laps ahead. Yeah. Okay. 4 laps ahead. And that is the 5th meeting. And that is what they want. So what are they asking for? Let's see here. What is the exact wording here? When Isabel passes Lila for the 5th time, how many times has Lila returned to point P? Okay. So that means when Lila has run, I should say, 212 units, how many times has she gone back to the starting point, which I think was here? Well, you have to divide by 12 then. So 212 divided by 12 is approximately 17 point something. So she's done 17 laps. Well, yeah, she's done more than that, but she's returned to point P 17 times. So returned to point P 17 times. So that would be how you would explain that question. Suppose that f of x is equal to 2 sine log x squared plus cos of log x squared minus 5. What is the value of f at pi? So we have f at x equal to, let's just put this in, sine of log pi all squared plus the cos of log pi squared and then minus 5. So we will use log rules. So this is going to be not really much we can do, I think, at this point. But this can be just kind of changed to 2 log pi. That's about it. That's not really dramatic. But then there is a trig identity that I think we can utilize. I just put it in brackets here, that cos 2x is equal to cos squared x minus sine squared x, like that. So I'm going to utilize that there. And when you do, you get 2 sine squared log of pi plus, let's see, that would be cos of log x all squared, right? Plus, oh sorry, minus the sine of log x squared. And then there's a minus 5 in there. Okay. So this and this would be sine of log x just squared, and then plus cos of log pi. Sorry, I should have put pi for x, but you guys understand. I forgot to do that, but that's okay. And then the minus 5. Well, this guy, you guys know, is equal to 1. Sine squared, that's one of the more famous ones. That sine squared of anything plus cos squared of anything is equal to 1. So in this case, our a is log pi. And then we have this minus 5. So, okay, 1 minus 5, negative 4. So it becomes fairly easy at the end, as long as you remember a couple of relatively straightforward trig identities. How many triples x, y, z of positive integers satisfy both x plus y plus z is a multiple of 3, and x is between 1 and 10, so is y, so is z. All right. Well, x plus y plus z is a multiple of 3. So fortunately, we have only a finite number to deal with, because x is between 1 and 10, y is between 1 and 10, so is z. So each of them only has 10 choices. So what we have to do is sort of make a little table here, and because the number is finite, it shouldn't take that long. So on this side, what I'm going to put is the remainder. The remainder when the number is divided by 3. Yeah. So, and the reason is because, I'll give an example. Let's say x is equal to 3, y is equal to 3, and z is equal to 3. Okay, then x plus y plus z would be 9. And is that a multiple of 3? Yes, it is. But let's say x was 3, y was 4, and z was 3. Now x plus y plus z is equal to 10. And is that a multiple of 3? No. So does that mean that x, y, and z all have to be a multiple of 3? Not necessarily, because watch what happens. Let's say I have x equals 3, y equals 4, and z equals, let's say, 5. Then x plus y plus z would be equal to 12, correct? And 12 is a multiple of 3. Now I say, well, how did that happen? It's because the remainders, when you add them up, are a multiple of 3. This is a remainder of 0 when dividing by 3. This gives a remainder of 1 when dividing by 3. And this gives a remainder of 2. So a remainder of 1 plus a remainder of 2. 1 plus 2 is 3. And 3 is also a multiple of 3. So if the remainders add up to a multiple of 3, then the sum will add up to a multiple of 3. So that's why I'm concentrating on the remainder. So the remainders could be either 0, 0, 0, 0, 1, 2. I'm only going to write the ones where the remainders add up to a multiple of 3. So 0, 2, 1, 1, 0, 2, 1, 1, 1, 1, 2, 0, 2, 0, 1, 2, 1, 0, and 2, 2, 2. Yeah, these are, because you notice, if you add up these remainders, there will always be a multiple of 3, either 0 or 3 or 6. Yeah. 1, 1. Let me just double check here. 1, 1. Yeah. So these are the only cases that are going to satisfy this. And then for the second point, then that's easy. There's only a finite number. For let me just put that over here like an aside here. For a remainder of 0, the numbers between 1 and 10 that give a remainder of 0 are 3, 6, and 9, right? For a remainder of 1, when divided by 3, those numbers are 1, 4, 7, and 10. Between 1 and 10, these ranges that they've given. And then remainder of 2, that between 1 and 10 would be 2, 5, and 8. So for a remainder of 0, we've got 3 possibilities. For a remainder of 1, we have 4 possibilities. And for a remainder of 2, we have 3 possibilities. So for the first one, we want x to have a remainder of 0. We have 3 possibilities for that. We have y to have a remainder of 0, 3 possibilities for that. And z to have a remainder of 0, 3 possibilities for that. So that's 27. Second one, we want x to have a remainder of 0. There's 3 possibilities for that. Y to have a remainder of 1. There's 4 possibilities for that. And z to have a remainder of 2. And there's 3 possibilities of that. 3 times 4 times 3 is 36. And you guys get the point. So this will be 3 times 3 times 4, which is 36. 4 times 3 times 3, which is 36. 4 times 4 times 4, which is 64. 4 times 3 times 3, which is 36. 3 times 3 times 4, which is 36. 3 times 4 times 3, which is 36. 3 times 3 times 3, which is 27. And then you got to add up all these guys. And when you do, you get a grand total of 334. So that is the number of triples of positive integers that satisfy both of those conditions. Rectangle ABCD has diagonal BD with endpoints B, 4, 2, and D, 12, 8. The diagonal AC lies on the line with the equation x plus 2y minus 18 is 0. Determine the area of ABCD. Let's first attempt to draw what this looks like. Okay, so this is not going to be drawn to scale, but I will attempt it. So let me just attempt to first draw So I'm going to say that that's B, 4, 2, this point right there. And then this one, 12, 8. That's all they've given me. That's D, right? And then they're saying that there is some, let's see here. Let me just, this is definitely not going to be drawn to scale, but you guys understand, hopefully. At least I'm attempting to make it drawn to scale. So then there's this sort of, there's a rectangle, and this, ooh, that was terrible, but you guys get it. Okay, so this point here is A, this point, and this point here is the C. So let's explain this. First of all, what's happening. So we got a rectangle ABCD, okay, that's drawn there. And we have a diagonal BD, has the endpoints, 4, 2, and 12, 8. Okay, those are drawn. Then we have a diagonal AC, that's also drawn in there. And it lies on this line. So this line is x plus 2y minus 18 equals 0. Okay, I got it. And then eventually we got to figure out the area of that triangle. Sorry, rectangle. Rectangle. Okay, so how do I do this? Well, the midpoint right here, this, if that's the diagonal, actually, I'm not sure. If I do the midpoint of these 2 points, right, that would mean 12 plus 4 divided by 2, and then 8 plus 2 divided by 2. So that's going to be 8, 5. But 8, 5 is not necessarily that point, because it could be here. Yeah. Or actually, the better way to say that is that 8, 5 is not necessarily on AC, this line right here. The only way I can prove that is I've got to go through a big long song and dance here. I've got to get the equation of that line that goes through BD. Okay, so let's do that. So first I got to get the slope. So rise over run, 8 minus 2 over 12 minus 4. And that's 3 over 4. So therefore y is equal to 3 over 4x plus k. And then substitute in any of those points. And when you do, you get k equals negative 1. And therefore the equation is 3 over 4x minus 1. That's the equation of this line right here. And then to get the intersection, which is this guy, then I've got to set those two lines equal to each other. So 3 over 4x minus 1 is equal to, well, I got to put this in the other form. So it'll be 18 minus x over 2 is y. Yeah, 18 minus x over 2 is y. And then when you solve for this, let me see, 3 over 4x minus 1, 18 minus x over 2. Yeah, when you solve for this, you'll get x equal to 8. And then when you substitute back in, you'll get 5. So indeed, that is 8, 5. And they'll just call that I, 8, 5. But I had to prove it with this. I can't just do the midpoint formula that I did there. So that's interesting. Okay, so now we can actually move forward with the actual heart of the question, which is trying to figure out the area. Okay, so to figure out the area, obviously I need the lengths of the sides. Now, B to I, that distance is very important because if I can figure out the distance, say from B to I, right, from there to there, that is the same as the distance from C to I, because I've shown that those two lines intersect there, and in a rectangle, the distance from the center to the corners will be equidistant. So BI equals CI. So that will help me figure out the coordinates of C, which I don't know right now. I'll just call it AB because I don't know what the coordinates are. Okay, so BI, I can figure that out using the distance formula, 8 minus 4 squared plus 5 minus 2 squared, right? So BI, when you crunch out these numbers, will be 5. Okay, so then since CI is the same, CI is equal to 5, so 5 would be a minus 8 squared plus b minus 5 squared. Hold on. I think this is under the square root sign. Yeah, sorry about that. Okay. And what do I do now? Well, I guess I have to solve this. So 25 is equal to 8 minus a squared plus b minus 5 squared, like that. But AB lies on this line, right? So that basically means that a plus 2b minus 18 is 0. So that means that a minus 8 is equal to 10 minus 2b if you just kind of rearrange it a little bit in order to make the substitution a little bit better. So that means that 25 is equal to 10 minus 2b squared plus b minus 5 squared. And therefore 25, you can factor out a 2, and then when you do, it will be, or factor out a minus 2, that will be more helpful, because that will turn this into b minus 5. And therefore, this would be 4 and then 1, so 5b minus 5 all squared. And therefore, b minus 5 all squared is 5. And then if we take the square root, it'll be root 5 plus 5, or negative root 5 plus 5 for b. Yeah. And then let's talk about this here. This is 5 right here, up there. So our value of y is lower than that. So it would probably have to be this one, because we got to choose one or the other. And then if we substitute back into here, we'll get a is equal to 8 plus 2 root 5. Okay, so we are getting down to the nitty gritty here. So now all we have to do is figure out the value for BC, which is from here to here, and then figure out the value of CD, and then to figure out the area, you just multiply those two. So let me just put that here. We're going to first figure out the value for the BC, and then the value for CD, and then in the end we'll just do BC times CD to get the area of that rectangle. Okay, so to get BC, I think we have the coordinates, right? Well, they're not very nice coordinates, but we have them. So we just use the distance formula for both. So BC would be 4 minus a all squared plus 2 minus b all squared under the square root sign. And then therefore we sub in a is this, b is that. And then when you do, you will get 50 plus 10 root 5. I'm just skipping through, you guys can do all the math. And CD, very similar, a minus 12, remember this is c and this is d up here. So it would be to a minus 12 all squared plus b minus 8 all squared under the square root sign. And again, substituting that for a, that for b, you're going to get 50 minus 10 root 5 all under the square root sign. And then finally, when you substitute it here, it'll be 2,000. And as a mixed radical, it'll be 20 root 5. So that is the answer to this question. Determine the sum of the real numbers x for which that equation is true. So the first thing I'm going to do is multiply through by the denominators to get rid of those fractions. X squared plus x plus 3 plus 3x times x squared plus 5x plus 3. And then on the other side will be x squared plus 5x plus 3 multiplied by x squared plus x plus 3. Okay, so then let's expand this whole thing. 2x to the power 3 plus 2x squared plus 6x plus 3x to the power 3 plus 15x plus 9x, and oh, this whole thing. When you expand and collect like terms, it'll be this. 18x plus 9. Okay, and then put everything on one side, collect like terms, and you'll get x to the power 4 plus x3 minus 6x squared plus 3x plus 9 is 0. Okay, so this is a monster. But there is a rational root theorem, and it states that the roots will be divisors of the final coefficient. So in this case, it's 9. In this case. So what are the divisors of 9? Plus or minus 9, plus or minus 3, and plus or minus 1. So that's it. So there's only 6 of them. It won't take that long. So you got to check them one by one. And when you do, you'll see that the only ones that work are -1 and -3. So they want the sum of those. So that sum would be -1 plus -3, and that is -4. A circle with center O is inscribed in the square ABCD having side length 60. Point E is the midpoint of AD. Line segments AC and BE intersect the top half of the circle at points F and G. If they intersect at point H, what is the total area of the shaded regions? So the first thing I'd like to do in this question is put everything on a coordinate axes. And when you do that, hopefully this will help. So let's label these. Since the side length is 30, and I've sort of put O in the middle, the coordinate axes, basically at the origin is O appropriately. This will be 30, 30, and then this will be 30, -30, and then D would be -30, -30, and then A would be -30, 30, and E would be -30, 0. And what else here? Anything else we can label? I think that's it for now. And then everything we're going to have to figure out. Okay, so the line between A and C, that line you can easily figure out is y is equal to -x. Right? That's fairly straightforward. And then the line that is joining BE, that, takes a little bit more work, but I'll let you figure that out. Fairly straightforward to figure out that line. We have 2 points. You find the slope, y equals mx plus b. Done that a million times. So now I want to find the intersection of these two lines, this one and this one. Set them equal to each other, so minus x is equal to x over 2 plus 15. And when you solve for x, you'll get x is equal to minus 10. And when you substitute back in for y, you get y equals 10. So intersection of those 2 points is H, correct? So H, this guy right here, is minus 10, 10. Okay, so that's a fairly decent progress. And now what I want to do is I want the intersection of the circle with the line BE. So BE and the circle. And when I do that intersection, that will give me G. So intersection, I guess. Okay. Well, the circle, that's x squared plus y squared is equal to the radius squared, which would be 30 squared. Wait, was it 30 squared? Yeah, 30 squared. And then BE, that equation is here. So I guess for y, I'd substitute x over 2 plus 15. And then solve for this. And I'll let you guys solve. I mean, you guys know how to solve it. And that'd be 18. When you substitute back 18, it'd be 24. So G is 1824. Got it? Okay, so now we turn to the regions that are shaded regions here. Now at first it seems like I was wondering what do I use? Do I have to figure out angles here? And then it kind of dawned on me that this point up here I'm going to label something as I'm going to need to talk about it. I'll label it I, this point right there. So the region that's AIF, right, that's actually already shaded, that is actually the same as AEF. See what I mean? Because of the symmetry of this diagram. So if I were to shade that in red, then essentially that fits in with the region. So this guy fits with EFH, and it becomes this triangle. And that's it. So to figure out those two, you just have to figure out the area of the triangle. So the area of the triangle AEH, right? AEH, or A, whatever, is 1/2 base times height. Well, the base is from A to E, which is 30. And the height is from there to there, which would be, well, the x-coordinate is -10, but you're going, you need a, let me think about this. You're going from -30 to -10, so that's 20. Yeah. So that means that's 300. Okay, so the only thing left now is to try to figure out the area of the triangle HGO. Okay, well, that shouldn't be too hard. Again, a 1/2 base times height. The base, let me think about this now. How do I do this? Okay. This is not as straightforward. Yeah, because that doesn't have a very obvious, but I think I can do it, because what I can do is I can take the triangle EOG, the big one, EOG, and subtract from it EHO, and that will allow me, to figure out HGO. Okay, so this will be 1/2 base times height minus 1/2 base times height. So EOG, the base is from E to O, so that's 30, and the height would be the y-coordinate of G, which is 24. And then for EHO, the base again is 30, and the height would be the y-coordinate of H, which is 10. Yeah. So then this, if we crunch out these numbers, would be 15 times 14. So 210? Yeah, 210. So then at the end, we just have to add that 310 with that 210. So 300 plus 210 to get all of the shaded regions, and that's 510. And 510 is the answer to number 25.